Hello everyone, welcome back to my YouTube channel. Today we are going to describe about unsample t-test and hypothesis testing. In the case of hypothesis testing, what we are doing is we are taking some decisions about population parameters based on sample data. Based on sample data with the help of statistical techniques, we are going to make some assumptions about population parameters using sample data. That is the case of hypothesis testing. And the hypothesis testing, actually there are three main things. It means two-tail test, right tail test, and left tail test. In the case of left tail test, we are considering lower than case, and in the case of left tail test, we are considering lower than case. In the case of right tail test, we are considering greater than case. In the case of two tail test, we are considering not equal case. It means in all the cases, one hypothesis is equal. The hypothesis that we are choosing as equal is the null hypothesis. So in the case of null hypothesis, either left tail, either two tail, or right tail, that is equal, because we are using this value to do the calculation. And also in the case of tails, mainly we are using two tail test, major case, because we have to consider most of the occasion we have to consider whether that is equal or not. And that is why we are using mainly two-tail hypothesis analysis. And that is a simple high-level structure of the hypothesis testing. In the case of left tail test, rejection region is at the left hand side. In the case of right tail test, the rejection region is at the right hand side. In the case of two tail test, the rejection region is in in the both sides. And there are several distributions, and here we are mainly considering about the Gaussian at the on the also we can say it as a normal distribution. But in the case of chi-square distribution, we are considering about the chi-square distribution. There are gamma distribution, and there are several type of distributions as well. But here we are mainly considering about the normal distributions to our most of the calculation. There's a reason behind that. I will say you in the future. And in here as the Z test, you can see those equations are very similar. Only the difference is this. Now it means here population is standard deviation, here the sample is standard deviation. When we know the population distribution as normal, and we know this population standard deviation, we can go for the Z test. On the other hand, if we know the population distribution as normal and we don't know the population standard deviation, then we can go for the t-tail t-test. But there is another important thing to be mentioned here. When the size of the sample is getting increased, the mean tends to follow normal distribution without considering about the distribution of the original data point. It means that if x is no distributed as normal, or imagine x is distributed as binomially, then but the mean of that can be distributed as normally. When the sample size is increasing, the mean tends to follow normal distribution in most of the occasions when the sample size is increasing. That is why we are considering normal distribution, and based on normal distribution we are doing several calculation also because of that reason. And here uh, I'm going to consider about the mean as well. Here the mean, and xy is mean of the sample, and here the xy also the mean of the sample. So based on the mean, we are going to do the t-test and z-test here. And now we can go for our example. In our example, I have used this example here. The example says that after cleaning the water, pH should be within 6.75 and 7.25 for better consumption. For that, they are taking pH values for few different samples as below, taking 0.05 as the significant level. Find out whether the pH value of the water is in the required range. That is what we are going to do. Then here we I use this because we have to conduct two types of tail test, because there is what the water should be in between this range. It means it should be higher than 6.75 and lower than 7.25. Therefore we need to be we need to have to do two tests. Between one test, in the case of one hypothesis testing, the H naught null hypothesis should be equal 6.75. On the other, it also in the case of alternative hypothesis, we have to consider population mean is greater than 6.75. Greater than 6.75. Then on the other hand, with considering 7.25, the mu should be equal to 7.25, and mu h naught is 7.25, and h1, it means alternative hypothesis should be mu is lower than 7.25. That is our requirement. It means because the water should be in these two range. We can't do a two-tail test here, because we have to consider the whether the water is in this region. That is what we need to be considered. And here, then to do the two-tail test, we need data. This is the data. This is include 14 data points, and here we have another requirement between the population must be normal distributed, but that is just an assumption. If there is enough data points, it means most of the occasion, if the sample size is greater than 30, definitely we can go for the t-test. But there is only 14 data point, but I will show you how to do the t-test here as well. And the t-test equation is t is equal, I will write down here, x bar sample mean minus population mean. I will say you what is this mu, and then divide by sample standard deviation divided by square root of n. This is called standard error. Both of these consider, it mean is divided by square root of n is the standard error. Here mu is what the population mean. If we know the population mean, why we are doing this test? Here we are checking whether the population mean is 6.75 or not. Like something like that we are doing. What is it? Because actually we don't know the population mean. We are checking that. Then that is in the null hypothesis. That's why we are always taking null hypothesis as equal. Because we need to have some value here. Mu is equal this value or mu is equal this value. We are checking that. That is why mu naught, it means h naught always in equal sign, because that is the reason why we are considering equality in h naught, to use that value to do this type of test. To do most of the tests, that is our requirement. I think that is clear. Then we are going to do the t-test, and what is now what is the thing that are required now is we need sample mean. We know the hypothesized mean, and we need sample standard deviation, and we need uh, square root of sample size. Here sample size is 14, and we need to find out mean value. But because of the, if I'm going to calculate now, it will be time consuming, so that I will use Excel to do that, and I will show you that. And then here you can see that clearly. That is the average of the data set. This is the average of the data set, mean mean, and this is the sample standard deviation, and this is the square root of n. And then I can write down the equation here. Between, we know t is equal 6.95 minus 6.75. 0.75 divided by S is 0.37 divided by square root of 14 is equal 3.7. So it is about 3.7. Then that is equal, I will show you here, then that is equal, that is the average value, this is standard deviation, and we can see that clearly here. It means our standard deviation as our standard deviation of the sample is, sorry, we have to consider about square root of n. Here square root of n is square root of 14. Yes, 3.74. I use that here, and 0. That is the way to do this. If I write down it again, if I write down it again here, I have to use 6.95 is my mean of the data set, and hypothesized mean is 6.75, and my sample standard deviation is 0.365. I can set this as 0.37 also, divided by square root of 14 is 3.74. And after calculating, I can take that as 2.02. That is a positive 2.02. Then we need to consider, we need to find out whether this value is in the rejection region or not. Then that is a right tail test. So we have to find out that, and that is a right tail test. It means one tail test, and we need then this degree of freedom. Basically, degree of freedom for the one tail test, it means, sorry, one sample t-test or z-test. One sample t-test, it is equal, degree of freedom is equal to df is equal to n minus 1. It is depending on the type of the test. It means for one sample t-test, it is n minus 1. And it is for two sample t-test, it is n minus 2. Not for two sample t-test. When there are two samples, here only one sample, so n minus 1 is the degree of freedom, and here there is 14 data point. Therefore, our degree of freedom should be 14 minus 1 is 13. Then again, then we have to find out that value. Then for that, we need to go to t-test, and here our significant value is, it means here our significant region, it means significant value we are considering is 0.05 level, and one tail test, and that is 0.05 level, and 13 is our 13 is, okay, you can see there is a value 1.77. So we can see clearly 1.77 is our test statistic value. It means the table statistic value. Then it means 1.77 is that this value. Our value is 2 points something, then that is greater than 1.77. So under 0.05 significant level, there is enough evidence to reject null hypothesis, because our calculated value is greater than the table value. Also, if we can calculate the probability value, this should be low. This definitely should be lower than 0.05. From a software, it will be given as sig value or p value. The p value should be lower than our significant level to have enough evidence to reject null hypothesis. It means p value should be lower than alpha value. Alpha value is the significant value that we are going to consider. So here the pH value is statistically greater than 6.75 under 0.05 significant level. Actually, we can say there is enough evidence to reject null hypothesis under 0.05. Because of that reason, statistically, we can conclude that the pH value is greater than 6.75. Then we have to go for the other way. It means we need to consider the other way as well, because there is another hypothesis. It is, what is that? That is uh, the thing with 7.25. Then we have to, again, we have here that is a left tail test, because we have to consider lower than 7. We have to consider mu as lower than 7.25 in the alternative hypothesis. Therefore, here we have to do a two tail test. There, sorry, we have to do a left tail test, and under the left tail test, then we can calculate, we find out the test statistic value as 1.77. That is not change, that will not change, because the group freedom is same. Only the thing is sign will be changed. For the left tail it will be negative, for the right tail it will be positive. And also here another thing we need to consider is, now we have to calculate our value. Then I have here calculate that, then I will use here all the things are not, we need to not be changed. I need to change only here. I have to use here 7.25. That is what I need to put there. Then my test statistic value is minus 3.10, because I put that h naught between h naught value here, and you can see mu mean this value minus this value, and here and this is this one divided by this one. This one comes from this division of this two. It means you can see s divided by square root of n. So I have done the calculation, and that value is again minus 0.31. It means when considering left tail test, that is lower than 1.77. In the case of left tail test, if the calculated test statistic value is lower than table value, then there is enough evidence to reject null hypothesis. Because of that reason, statistically we can confirm that the pH value of the data is in between 6.7.2, 6.75 and 7.25 for the data set. Therefore, that water sample is better for consumption. That is the thing with one tail test. Then we need to be consider about Z and Z test and Z test and two tail t test as well. This is a case for Z test here. Why I am saying this as Z test? Because a researcher claimed that log CPU bacteria should be equal to 5.0 to obtain a better result. If we can assume normal distribution of log CPU of bacteria follows a normal distribution with 0.05 population standard deviation. Then we know the population standard deviation as well as we know the distribution of the population. Therefore, we can go for the Z test. In the case of Z test, what we have to do is we have to calculate that Z value. Again, then Z value is equal to, we can calculate using that equation the Z value. Z value is equal to x bar minus mu comes under the h naught divided by sigma over square root of n. Here sigma over square root of n, because we are considering the mean distribution of the mean. That's why we are using sigma over square root of n. If here you are using x, then this will be only sigma. And then here our null hypothesis is h naught should be mu is equal 5.0, and h1 is mu is not equal 5.0. H1 should be mu is not equal 5.0. So that is a two-tail test. Two-tail test and two-tail one sample is a test. And here the values are given as 5.10 minus our H naught is 5.0 divided by 0.2 divided by square root of 12. Then this square root of 12. We have to calculate this value as well. And to calculate, I have to use here square root of 12. I need to be considered here square root of 12. And here population standard deviation is 0.2. And here my value is 5.10. And here this should be 5.0. This should be 5.0. I think you can see clearly those things. 5.0. Yes, that is all. 5.1 minus 5.0. Here D7, this one divided by this one. So the equation is correct and my Z value is obtained and Z value is 1.73. So Z value is 1.73, the calculated Z value. Then this is two-tail test and we need to find out our Z value for this. So what is our Z value? Since this is two-tail test, we have to consider about the two sides. So in the case of two-tail test, we need to be consider about the 0.25. If the alpha value, it means significant value is 0.05, we need to consider the 0.025 level from both sides. That is the difference between that. Because the sum of these two should be equal to 0.05. Because we are considering whether this is not equal. It means it should be higher than this and it should be lower than this. Therefore, we have to divide that our sigma required significant level by 2, and based on that we need to be calculate the Z value. Here then, so basically it is easy to go from the right hand side. So from the 0.5 to there we have 0.4 0.5 minus 0.025 is 0.475. So because from here to here, this is totally, there is a 0.5 region, and after reducing that will be 0.0475. And then we have to go for the Z table, then we need to find out 0.025 from here. 0.025 sorry, 0.0475. It means 0.975 because I am using here from the I'm considering a negative as well. Now I have to consider 1 minus 0.025. Then in that case, in that scenario, I have to go to 0.975. I think you can understand because from here I have to consider. Then 0.975 I have to consider 0.975. Okay, there's the exact value 1.90123456. 1.96 is the, yes, 1.906 is the 1.96 is the our calculated Z value. Then sorry, table Z value. Then our calculated value is 1.73. Therefore the calculated value is lower than our value. It means, and also it is higher than negative value. You can see that clearly because that should be definitely, and it should be in this region, inside this region, and 1.73 is somewhat in here. It means somewhat in here, 1.73. Therefore, it is in the accepted region. It means we don't have enough evidence to reject null hypothesis. Then we can say under 0.05 significant level, we can say the log CPU bacteria is equal to 5.0. It means it is not different from 5.0. There is not no enough evidence to say that it is different from 5.0. That is the conclusion we can obtain here. Then I'm going to do the same example using t-test as well. We will say what will be the conclusion of that based on t-test. Then what we have to do is, I will show you, because here the only thing is, in this case, the only thing is a researcher claimed that the log of a bacteria should be equal to, that is the case, and if we can assume the distribution of bacteria follows a normal distribution and the mean of the log CP of 12 is that value with 0.020 sample standard deviation, find whether the requirement is achieved or not. Then here we know the population standard deviation, but here we don't know. So then we have to go for the t-test, and two tail t-test we have to be considered. Then t is equal, t value, t is again equal, we know x bar minus mu h naught value should be given here. You know now that s divided by square root of n. Then actually the values cannot be changed because I use same value. The equation I use same value, therefore the value should be 1.73. The value should be 1.73. Now our degree of freedom is 12 minus 1. Degree of freedom is 12 minus 1. It means degree of freedom is 11. And our degree of freedom is 11, and now we need to go to t-test. We need to go to t-test table. Then our t-table, our degree of freedom is 11, and we have to consider two tail tests, and we can go here, means we can see clearly, we don't not to be worried, just go for 0.05, and then we have to go for, okay, this is the value 2.201. Z value is 2.201. So you can see that is 2.201. Again, the same conclusion that can be obtained. But you can see some similarities. It means we have 1.96 as the Z value, and T value is 2.2 something. Then you can see the spreadness of the T distribution is little bit higher than the Z distribution. Also, you can see another important thing that I have said, that when the sample size is increasing, the t-test tends to follow a normal distribution. You can see that clearly here. You can see when the sample size is about 1000, you can see the Z value and the T values are almost equal. That is why we are saying that when sample size is increasing, the mean of the sample tends to follow a normal distribution. But that is actually basically, if it is greater than 30, that is enough in the normal cases, and that is it. And also another thing to be mentioned here, here again, if I go back, the conclusion is same. I have to say that another thing, it means, I think you can see that something is clearly, it means, imagine here, here the test statistic is 1.73. Because of that reason, we can, both of the Z and t test give the same answer. But if that value is 2.01, then under t-test, null hypothesis is accepted, but under Z-test, null hypothesis is rejected. So I think you can understand, we need to be carefully choose the distribution as well. That is the thing with the t-test. And subscribe my channel for more of these videos.